Today, let's create a CNC program for our advanced manufacturing technology practical one. For that, let's create the part first. That part, let us keep it as linear and circular interpolation part. Okay, this one is part. Let us uncheck this CD for template. Go to MMS solid relative. Okay, and let's sketch it in the front plane so that we can revolve it. Let's revolve it in the front plane and let's view the sketch. Let's draw a line first at somewhere. Let's control this dimension. Before that, let's do the same thing. First, let us create the center line. Okay, because we are going to revolve it. Okay, then let's select a line from this to this and let's stop it here. This diameter is 30 mm as per the input drawing we got. The first length is 20 mm. Now let us continue with the next one is an arc, but let us continue with the line with the gap somewhere not equal to end. Another arc, let's create somewhere here and end it. And this length is 15 mm. Okay, and this one is again 15 mm. Is that 15 mm? And this dia is 20 dia, 20 mm dia. This one is 25 dia. Okay, now let us dimension this gap. Okay, this one is 10 mm. Okay, and let's dimension this one also. Okay, this one also 10 mm. Now we have to create an arc. Okay, center point arc will not work. Let's try something. Okay, it should start from here to here, end it. It looks nice, right? Okay, and then let's create one more arc from here to here. Okay, enter it. Contingency is there. That's all. But let's check whether this radius is no. It should be 15, right? Then where no, cancel it, delete it. This should be deleted, and this arc should be not from here to here. It should start from here to there. Okay, let's give the dimension now. This dimension, where it is. Okay, which one is constraining? Linear, horizontal, linear. Let's delete it and see. It should be 15 mm. Oh, that's the reason. To be very careful. Right. But if you constrain all these dimensions, this one. See, it will disturb the entire model. Okay, we have to set this dimension to this and undo it. In this this radius, how it is coming. Okay, let's see, it should be 21 exactly. So that 10 mm is driving. Let's keep it 15 then. Okay. And then here also, let's keep this. This 10 mm is driving. Here also it's 15 mm. Now let's see. Okay, whether this falls in line. Okay. Then connect these lines. Let's see how the overall. Okay. This looks nice, right? 15, 15, 15. Whether this is 10 mm or not doesn't matter. Let's give this dimension, overall dimension. Oh, 1, 2. Let's try to give this dimension, otherwise. And let's give this dimension. 66.58. Because it's driving. Which one is driving? Radius is driving, two radiuses are driving, and this length is constrained, and this dia, it's 20 dia, right? Everything is constrained. This one is also constrained, this one also constrained, this one is constrained. Okay, now we can't compromise anything with this. Okay, okay, okay. Okay, let's keep it as it is and do anything. Leave it. Okay, this is the part we want. Close it and complete the sketch. Let's save this part first. Okay. Now we are going to create a CNC program. Let's go to new file and select manufacturing and NC assembly. Now we are going to create linear and the circular interpolation. Okay. Okay. And here also we have to select the same. Okay. And now let us bring in the reference model. The reference model is this part file. Okay, let's fix its position to the default location. Fully constrained. Okay. Okay, let us see this. Why it's not showing? Model properties. It's still there in the absolute position. Let's give it. Okay, we have to assign the material. Change the material, standard materials. Let's give plastics PA6 with the black. Okay, PA6. This one is polyamide. Usually it is called. Okay, and then let's bring in here, and then let's let us see. This one is applied. Okay, okay. Now it's okay. This material is assigned. Okay, PA6. Okay, done. Okay, not assigned. We have assigned, right? We have assigned the PA6. Okay, save. Why it's going somewhere? Okay. Just don't want to see this. This is applied now. Okay, that is doing some errors. Let's go back to the part. Here, let's assign that material. Let us assign that material and see that PTC Pro material. Let's give our favorite material, plastic material, PA6 for nylon usually, or amide for nylon. Okay, let's bring in closer and let's down it so that we can see the OK button. It's assigned right now. Material is assigned. Let's see the model properties. Okay, yes. Yeah, no, it's not taking it. Plastics PA6 material. Yes, now it's assigned. Save it. No need. We have assigned it. This arrow is must. Then you bring in here, somewhere here. Then bring it down. And then, okay. Material assigned. Close it. Okay. Okay, everything restore as of now. Okay. Save it. Okay, then go back to the NC assembly and regenerate it. The material tag has come. PA6. Okay. Okay, save it. Now we have to create a reference datum plane. In this phase, with the offset references of this plane and this plane. Okay, and let's give 0, 0. Okay, the star is fine here. X upward is at pointing in the spindle direction, axis of spindle. Okay, now let us assemble an automatic workpiece. Let's refer this and then give okay, let's make it okay, 30 mm, no problem. And this length, instead of this, let's keep it 100 mm. Okay, but this goes both the way. This side, let's keep it 0. So that now what happens? 83. Let's keep this as 100. Again, this one 0, this one 100. IH. Okay, now let's keep it as it is. Let's keep it 100. Okay, this 100 mm length. This extra material, let's phase it out. This extra 2 mm offset so that this will look nice. Okay, so our geometry. This will help us to hold the material there. Okay, now let's go to the work center. Let's use lathe for doing this linear and circular interpolation. And one more thing, let's edit this workpiece. Edit this workpiece. Let's keep it 32 then. Okay, the 2 mm extra. Okay, and then let's go to the work center. It's lathe. The lathe, we are going to select the tool, set turret 1. The tool, we can keep it a nose radius of some zero point 0.8. Okay, and this one, let's keep it somewhere 15 mm, and this one, let's keep it 10 mm, and this one, let's keep it 45. This is 120 degrees and this one 15 degrees. Let's apply it. Okay, now tool is done. Okay, restore is by default. Okay, and okay, save it. Now we are going to define the operation. This operation with respect to this work datum plane, and with an offset plane. Okay, this is where the clearance starts. Okay, let's keep it like that. Tolerance, let's keep it 0.001. Okay, okay. And then the turn menu has come here. Let's create a turn profile. Let's go for automatic turn profile. This is what we are going to turn, but here it will be not done. Here first let's start and do some freezing, and after that everything is turning. From here to here it's linear interpolation, from here to here it is circular interpolation. Okay, start. Okay, now first let's start with area turning. This is nothing but our rough turning. Okay, now see that how the material is being removed. Okay, let's give okay, but this profile it should stop here itself. Why it's going there? Let's see. Okay, now let us see the tool path. Yes, it goes up to there, but we are not stopping there. We should stop there, right? It usually takes some time. Let's close it. So this is for learning purpose only. Let us keep that workpiece at exactly some 67 something, right? Okay. Now let us not waste over time and machine time also. Now let us simulate it, save it and simulate it. For simulation, simulate it. Okay, yeah, it's stopping there. Okay, 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 okay. That's how it's going to machine the part. Okay, now this is done. If you want to see the real material simulation, removal simulation, okay, let's simulate it and see that shape you are getting. This is what we are going to get after machining from the rod of 32 mm dia and 67 mm length. Close. Now we need to create a CNC program. Okay, for that we have to save a CL file, NC sequence. the area turning wheel selected and file and MCD file done. Okay, save this area turning CL file, cut the file, then OK. And in this, let us select a lathe. Let us select a lathe, this one maybe. So it takes some time. G post lathe built number input file area turning NCL is cutter location file. That's it, done. That's it. Our NC program. Our NC program is ready now. The NC program is there in the tab file. Okay, open it and see it. This is how the NC program is getting generated. And this will work exactly as per the simulation in the actual machine also, which has the Fanuc control board. Okay, thank you for watching this video. Okay.